Welcome to the group exhibit Hydrogen, Fuel Cells and Batteries at the Hanover Fair 2017. We're here at a technical forum. Right now we're having presentations regarding fuel cells and their components. It's the third presentations of the day. I'd like to welcome Hanson Ruan on stage with me. He's the CEO and CTO of Blue O Technology. And he will talk today about the plate-shaped platinum catalyst booming hydrogen PEM fuel cell. Stage is yours.
Thank you very much. Hi, everyone. Today we're going to introduce our novel technology for PEM fuel cell catalyst. So today we'll give you a brief introduction what is the PEM fuel cell if some of you do not know. Also, I will straight lead you to the advantages of our PEM fuel cell catalyst. Then we'll also take you to one slide talking about how to make them, how to make sure the quality is there. Then also we'll give you a little flavor. So our technology also enabling non-PGM catalyst processing. And I'll give you a brief summary at the end. So this is normally how a fuel cell runs. You put hydrogen on the one side anode, oxygen on the cathode, contact the membrane in the middle. With the catalyst layer, you generate electricity. The beauty of this kind of battery is only give the pure heat and pure water as a byproduct. And the main thing considered here right now, the mature catalyst is based on platinum. And as we know, platinum is very rare and it's very expensive. So look at the market price. Everybody wants to do PEM fuel cell because of scalability and the power range. And I try to aim at a very low cost in 2017, this year, down from 275 kilowatt per kilowatts to $30 per kilowatt. It's almost impossible because we know in the market price, during the reality check, we know it's around 150 to 400 euros per kilowatt at this moment. And also lacks the water renown, market research renounce. If you sell a fuel cell vehicle at 50K, how much is it going to cost you every year? And we know maintenance and fuel costs quite significant at this stage. So in order to bring the gap between the cost down to target cost at $30 per kilowatt, they must have something innovative. So why are we talking about a plate-shaped supported platinum catalyst? Because simply, if you look at the spherical balls, most companies they are making, for the surface chemical reaction, they only utilize surface area on the surface spherical balls. And if you compare the plate shape, you slice them to 3 discs, you can expose 3 times more surface area than a spherical ball equal size at equal mass. Equal mass. And this is a huge advantage for us. It means you can have 3 times more surface area if we utilize a plate-shaped catalyst. Also, for those plated catalysts, they have more active sites accessible by hydrogen than the spherical balls, because spherical ball is energy minimized structure, so they have well-defined active sites. But our plate-shaped catalyst has small pores and polycrystalline structure, give you much more active sites. So you have more active sites, much less platinum and more power. So this is the EM electron microscope show you. We do see these spherical plates on carbon support. And we know uniform thickness leads to uniform contrast if you learn the electron microscope. This is what we're taking in 2012. But in updating in 2014, you can see we can make a very uniform size, narrow size nanoparticles. Those gray-shaped or dark-shaped, those are platinum particles. All the light gray contrast are the carbon support. And if you look at our size distribution, we get 90% of the nanoparticles at the range 2 to 3. Why is 2 to 3 important? Because this has been found the most efficient nanoparticle size for PEM fuel cell. So we have exceptional narrow size distribution and uniform deposition over all the substrate. So in the middle, this part is just a vacuum. So everywhere you see those bumpy things, those were the transparent graphene-like substrate. And we not just have a surface area advantage or active size advantage. We also have other advantage. We are not sensitive to the ionomer. Ionomer was used to bind the nanoparticles on the membrane. And for those platinum catalysts, supported catalysts, they are very, very sensitive to the ionomer used in the ink formulation. And for our catalysts, it doesn't matter because you only cover where the base is. You don't cover where the platinum catalyst surface is. And we run the polarization curves to show what the electrocatalytic activity is. We use a Ballard stand test kit against our BO is below 60% loaded platinum catalyst. You can see we use 1/4 of the total loading, matched the 0.5 standard loading MEA. So it means they are very strong performance here. We also obtained better performance at ultra low loading. You can see at almost around 0.64, you got a 1.9 amps. And this is very powerful. Tells you can use our catalyst to make whatever you like. Means in the power range, power density, and no one has achieved as we can achieve. But that's stop here is not saying no catalyst can perform like this, but they do not perform as durable as we can. Because if you look at what those spherical catalysts they do, because they're dissolving, oxidize, they're dissolving, all right? So they're redepositing, grow the nanoparticle size, and they lose surface area again. They also migrating, become aggregated together. They also lose performance. But if you look at the plate structures, the diagram right here, it doesn't matter because on the surface you can dissolve, redeposit, dissolve, redeposit. It doesn't have a way you will deposit to adjacent spherical balls. So this is a more stable, more durable catalyst in your MEA. We're not just saying so, we also demonstrate our durability compared to the standard commercial sample. You can see after 20,000 power cycle by DOE AST 2015 standard protocol, we run under the identical conditions. They lose 80% of performance, means non-use. After 4 years, you cannot drive. But if you look at ours, it's only lose 36%. DOE standard is 40%. So we're still below where the DOE category is. So it means after 5 years, you may drive next year. Now, as I showed you, you may wonder, how do you make this guy? Are you sure this is, you can do very good quality control here? But if you look at, we use a totally different process. This is called photochemical process. We put the platinum precursors, organic precursors, on the support. We use the intense UV light to decompose them. Listen, we directly deposit platinum atoms on the support. Not like any impregation method, they reduce platinum in the solution. They impregnate it on the support. They are very different process. So we directly deposit platinum on the support. So they are very strong, like a physical deposition. Okay? And also, we can really control how the distance between each particles. And because this process is almost semi-auto control, so there is no variable parameters to change the quality of the nanoparticles. Also give you guaranteed batch quality. All those impregnation methods produce batches, they varies because they cannot produce consistent quality nanosize particles. And don't forget, I remind you, we produce 90% in the size range you want. And give you a quick summary, you can see our plate shape catalysts produce more, have more surface area, more active sites. We're also less sensitive, means that when you do production operation, you get a better engineering opportunity. And it's stable, as durable in the MEAs. And then we also have achieved at least 1.22 watt at 0.643 volt. And our process also guaranteed our catalyst, if you want to buy or work with us, have a quality catalyst from batch to batch. You don't need to keep your senior scientists on site every time to check your catalyst quality. We also, at the last, we want to give you a flavor. We also can do non-PGM catalyst. Why? So we just need to replace platinum with transition metals or rare earth metals. Make same process, plate-shaped. Use the same process, make a plate-shaped supported catalyst for PEM fuel cell, if that is what the future lies. And let's go back one slide. Here it says everything's in place. If industry utilize our plate-shaped catalyst, you will definitely have a mass market for yourself. And thanks for your time.
Thank you very much. Your warm applause.
Thank you. Can I answer any questions you have?
Any questions right now? If not, he will be available at the
there's
booth.
One.
Oh, there. Great.
That's a professor.
Okay, thanks. Nice talk. Did you measure active surface by some electrochemical analysis?
It's around 68 square meters per gram.
Per gram. Okay, thank you.
Yes.
Further questions? Otherwise, I would like to thank you one more time. He's available at the booth 41, right in the back, right there. Go by, have a chat, ask your questions. Yes. Thank you one more time.
Thank you very much.
Thank you. And the next presentation will start in about 5 minutes. It will be regarding latest developments on graphite bipolar plates and gaskets by Eisenhut GmbH. Please stay with us, have a coffee, have something to drink, help yourself. It's all free. Thank you.